This is June 2018, question number 9, geometry and trigonometry. So question 9a shows us a diagram that I have sort of recreated, not drawn to scale, which shows the relative positions of three reservoirs, B, F, and G, all on level ground. Level ground tells us that it's horizontal perfectly. That is the condition that we are assuming. The distance PF equals 32 kilometers, as we see. FG is 55 kilometers, that we can also see in the diagram. The angle at F, BFG, is 103 degrees, and the bearing of F from B is 42 degrees. Now, the first question asks us determine the bearing of B from F. All right, so the thing about bearings is that bearings are angles that are measured from the north line in a clockwise direction. So you must first put this north line right straight up. It is assumed to be perfectly vertical even when you draw it, and what I have done to get that angle there marked in, right, I have extended the line BF, and what that allowed me to do is to use corresponding angles, because this angle will correspond with this one up here. So I know that this is 42 degrees. I also know that angles on a straight line add up to 180. Therefore, the bearing of B from F is 42 degrees plus 180 degrees, which is 222 degrees. So part 2 of this first A. Calculate the distance BG, giving your answer to 1 decimal place. So for BG, we want to use the cosine rule. Why? The cosine rule is usually applicable when you have this three tandem thing. You have this line, the angle in between, and the length of the other line. When you have these three things lined up in a row, you know immediately that it's going to use cosine rule. So from the formula sheet, I have that BG squared is equal to this entire thing. Do not work this out, then work this out and subtract that and then multiply by the cosine. That would be entirely wrong. I have seen students do it for years and years and years. Enter this exactly as into your calculator. Get the answer. Square root the answer using that alpha button on your calculator. And then because you wanted to 1 decimal place, it becomes 69.6. Simple, 2 marks. Final answer, the beginning line. Oh, sorry about that. Part 3, the bearing of G from B. So when we look, the bearing of G from B, so we need to get this angle here, right? This is the line that connects B to G. We know it is 42 plus some angle here that I'm going to call theta. So 42 plus angle FBG. For angle FBG, use the sine rule. So A over the sine of the opposite angle, B over the sine of the opposite angle, also in your formula sheet. Plug in everything, multiply, divide, move stuff across, and you will get that that angle is 50 degrees. Therefore, the bearing of G from B is 92 degrees. All right, but we're not finished. This is just part A. Part B. Okay, so we will give on, it's a circle theorem question, we will give on this diagram that I've tried to recreate, and they wanted AB, angle ABC, right? So there's this angle here. So let's just go. The first thing I do is put what I know. AB is obviously diameter, and any angle subtended by the diameter is 90 degrees, and that means this is 90 minus 58, which will give us 32 degrees. So this is actually 32 degrees. I just put things in, so the reasons are what I said before. Then they want CMB, so we want this angle here. Okay, well, ABMC is a cyclic quadrilateral, right? As you can see it, a cyclic quadrilateral, that's how you spell it, in case you want to look it up in a textbook. And the cyclic quadrilateral opposite angles add up to 180 degrees. So actually for CMB it will be 180 minus 58, which will be 122 degrees, right? And you can put cyclic quadrilateral as your reason. Next we want NCM. So we want this in the corner here. Alright, this is 90. This is a straight line. If this side is 122, then this side has to be 58. Right, we just did that thing. That side has to be 58, and then this must be as well 32, because we had that same. It's similar triangles, similar because they're not the same size, but they have the same angles. 90, 58, 32, 90, 58, 32. So they are similar triangles, not congruent but similar. So NCM is 32 degrees, and I'm just going to put angles in triangles. For this up here, I'm going to put, I don't know, subtended by diameter. All right, and that is question 9, 12 marks.